Hi everybody, it's Miss Lorenz. This is the topic 1.2 in the 7th grade book. I want you to follow along on pages 15 through 17. So I'm always going to want you to do those example pages, reading through, and this is my little mini lesson that goes through that as well, so that you can hear from me and have a little more explanation that goes with it. All right, so in this lesson, we're talking about terminating decimals versus repeating decimals. So a terminating decimal, we know that the word terminate pops out here. That means to stop. So these are decimals that stop and basically don't continue going with like any sort of remainder. They stop or they end with a 0. Repeating decimals, they repeat. And what's important that you remember here is that they repeat with like the same number, like 0.33333333 or 0.1616161616. But a decimal that doesn't repeat, that says like 0.141444, 1444, 14444, 1444444, it seems like it might repeat because you can see a really cool pattern in there, but that is not a repeating decimal. This has the same part of the decimal repeating. All right. So when it comes to terminating decimals, we're going to go ahead and divide these problems just as examples. So I have written here 52/80ths. I want you to remember that the fraction bar is a division sign. I always like to write division with a fraction bar to remind students of that. The number on the bottom, the denominator, always goes into the number at the top or the numerator. So when I would write this as a long division problem, I know that my 80 goes into my 52. And a lot of times kids flip that around because they think, well, 80 can't go into 52. Yeah, exactly. This is a fraction. It's not even 1 yet. It lives between 0 and 1. So we're going to put a decimal just like this. All right, so now when I multiply, or when I try to figure out how many groups of 80 are in 52, I know that there are no groups of 80 in 5 and no groups of 80 in 52, but I know that there are 6 groups of 80 in 520, because see how I'm going to look at that as 520 now, and then I've just put the decimal up above, and that equals 480. And then when I subtract, I end up with 40 as a remainder. Now, maybe when you were in elementary school, we wrote up here, remainder 40. We're not doing that anymore. We're going to keep going. So as soon as you have a decimal, you can continue to add zeros as needed. We don't necessarily go like forever and ever and ever, but what we're going to do is continue our decimal as far as what is reasonable. So 80 into 40 is what I'm looking at here. How many groups of 80 are in 40? Well, none. But I do have a decimal here, so I can add a 0. So I'm looking at how many groups of 80 are in 400, and I know that that is 5, because I know that 8 times 5 is 40. And so 80 times 5 is 400, and then when I subtract, I get 0. Ah, see, I subtract and I get 0, so I know it's a terminating decimal. So my decimal equivalent to 52/80ths is 65 hundredths. Let's do the same down here. We're looking at 240 384ths. So again, the number on the bottom, the denominator, goes into the numerator. So this is our divisor and this is our dividend. This is what we're trying to figure out. We're trying to figure out how many groups of 384 are in 240. And I know you're thinking, well, there aren't any groups. Well, that's right, because we're looking at a number that's less than 1 but greater than 0. So we're going to put a decimal after 240, add a 0, just like this. Now I'm looking at how many groups of 384 are in 2,400. And I can start with 6. I know there are 6 groups of 384 in 2,400. And when I multiply 384 times 6, I get 2,304. So when I subtract, I end up with 96. Now, I don't want to just write remainder 96, just like before. So we have a decimal, so we can just go ahead and add a 0. I'm going to go ahead and add a 0 here. I know that I can go 384 2 times, and 2 times 384 is 768. And then when I subtract, I end up with 192, if I did that correctly. I'm not done yet. And again, I don't want to write remainder 192. I want to add a 0. Keep going, see how far I can get. Then when I see how many groups of 384 are in 1,920, I know I can get 5 groups out of that, which actually ends up at 1,920, and I end up with a 0. Terminating decimal. All right, let's go ahead and talk about repeating decimals, and then we'll go through a couple examples. Repeating decimals continue again with the same digits, all right, without end. So in this case, 18 is our divisor. We want to figure out how many groups of 18 are in 5. Well, there are no groups of 18 in 5, of course, so we have to add a decimal and a 0. Now we're looking at how many groups of 18 are in 50. Well, only 2 to start with, so I'm going to go ahead and multiply 2 times 18, and I get 36, and when I subtract, I'm left with 14. I'm not going to write remainder 14. What are we going to do? We're going to add a 0 and continue to divide. How many groups of 18 are in 140? 7. And 7 times 18 is 126, and when I subtract that, I end up with 14. Ooh, that seems like deja vu. We're not going to write remainder 14. We're going to add a 0. And then I notice, whoa, I just did this. How many groups of 18 are in 140? 7 again. Again. What? There I have 14 left over again. Add a 0. Goes in there 7. What? 14 left over. This is going to continue forever. So I know that this 7 is repeating, so I would actually write this decimal as, with my point, 2, and then I would put a line over the 7 to indicate that it is repeating. All right, let's do the same with 100 divided by 3. We're looking at how many groups of 100, or how many groups of 3 are in 100. 3 is my divisor, and you might be thinking, whoa, this time we can do it. Yes, we can do it. 3 doesn't go into 1, but 3 goes into 10. Goes in there 3 times. 3 times 3 is 9. 1 left over. We can bring down the 0. 3 goes into 10 3 times. 3 times 3 is 9. 1 left over. I don't want a leftover, and I don't want to write a remainder. So, a couple things we could do here. We could, these are our options, we could write our remainder as the numerator of a fraction, and the divisor would be the denominator. So this would be 33 and a third. But since we're working with decimals, we're going to continue and turn it into a decimal. So I'm going to plop a decimal down, and then that sort of allows me to add a 0. And I keep going. 3 into 10, well, again, it goes 3 times. Subtract to get a 1. I already have a decimal, so I can keep adding a 0. And I'm going to notice that every single time the same thing happens, right? So I know that this 3 is repeating. So I would write this as 33 with a repeating 3. So these are our 2 ways that we can write our answer to this problem. Okay, I hope that helped everybody. Look at the assignment that you will do starting on page 18, and you can get started. Thanks for listening.